Once we have remembered the formulas of the generalized form, we can let A be number 1 to get the formulas of the basic functions, because x can be written as x over 1. And now let's recall these formulas together. For inverse of sine, we will have 1 over root sine. The fraction is x over 1, so 1 squared minus x squared. And for second one, we have inverse cosine. Then we will have negative 1, then root sine. Then the fraction is x over 1. We will have 1 minus x squared. For inverse tangent, we will have 1 over and plus. The fraction is x over 1, so 1 squared plus x squared. Since a is equal to 1, the numerator times 1 is still 1. The first two formulas are valid for x between -1 and +1. Endpoints are not included. The last one is still valid for all real numbers of x. Now let's look at the application of these formulas. Let's start with part A, where we have inverse sine x on 3. We can use the generalized form, the first one, where a is equal to 3, and we will get the derivative immediately. dy dx is equal to 1 over root and 3 squared minus x squared, and it can be simplified to 1 over root 9 minus x squared. This result is valid for x between -3 and +3. Endpoints are not included. Now let's move on to part B. We have y equals inverse cosine 4x. For this question, we can still use the formula of the generalized form, the second one. But we have to identify the value of a. We will convert in this way: 4x. It means 4 times x. And for multiplication, the commutative law applies. So it's the same as x times 4. Then times can be converted to division, and this divisor will be converted to its reciprocal. Therefore, it's equal to x divided by 1 over 4. Then this division can be written as a fraction, x on 1 over 4. Therefore, the function can be rewritten as inverse cosine x over 1/4. Therefore, by comparing with the formula, a is equal to 1 on 4. We apply the formula to get the result. dy dx is equal to -1 over root sine, and denominator is 1/4. This one is squared minus x squared. This value can be simplified to -1 over root 1 over 16 minus x squared. It can be written as, after that we will have -1 over root 1 minus 16 x squared over root 16. And root 16 can be simplified to 4. Then the denominator is a fraction, and we can convert it to multiplication and flip this fraction. We will have 4 over root, and final result is -4 over root 1 minus 16 squared. This result is valid for x between -1/4, +1/4. Endpoints are not included. This is first ideal. We can also try a different method. The chain rule to find the derivative. Since y equals inverse cosine 4x can be considered as the composite function, where the inner function is 4x and outer function is the inverse cosine. Let u be 4x, and then y equals inverse cosine u. By using the chain rule, we will have dy dx equals dy du times du dx. For the outer function, the inverse u, we can just use the formula of the basic function to get the result -1 over root 1 minus u squared. Then for the inner function u equals 4x, the derivative is equal to 4. Then we will have -4 over 1 minus u squared, and u will be replaced by 4x. Therefore, final result is, and u should be between -1 to +1. It means 4x is between -1 to +1. Therefore, x is between a quarter. By comparing these two ideas, both are pretty good. For the first idea, we use the generalized formula directly, but the key step is to rewrite the function to identify the value of a, which is a quarter. And the second idea, we use the chain rule, and the key step is to distinguish the inner function and outer function, and then apply the chain rule. Now let's move on to part C. We have the function y equals inverse tangent 2x on 3. We can try two different ideas. The first one, we are going to connect this function with the formula of the basic form. Then we will rewrite this function as y equals inverse tangent, and x as the numerator, and the denominator we will have 3 on 2. It tells us the value of a is equal to 3 on 2. We will apply the formula to get dy dx. It is equal to a, which is 3 on 2, over a squared, 3 on 2 squared, plus x squared. And we will simplify this fraction in this way, 9 on 4 plus x squared. Then both numerator and denominator times 4. Then we will have 6 on 9 plus 4x squared. And this result is valid for all real numbers of x, since it's the inverse tangent. Alternatively, we will use the chain rule to solve this question. Let u be 3 on 2 times x. Our function is equal to inverse tangent u. Now we can get the derivative of each function first. For du dx, 2 on 3, and dy du. And this we will need the formula of the basic form about inverse tangent. It is equal to 1 over 1 plus u squared. By the chain rule, dy dx equals dy du times du dx. And then we substitute the relative derivatives to get 1 over 1 plus u squared times 2 on 3. Then u will be replaced by 2 on 3x, and we will have 1 over 1 plus 2 on 3x all squared and times 2 on 3. Simplify it further, we will have 1 over 1 plus 4 on 9x squared, then times the fraction. The denominators will be 4 on 3x squared. Then both the numerator and the denominator are multiplied by 3. Then we will have 6 on 9, and this one we will have 4x squared. Obviously, we have obtained the same result. Idea 1, identify the value of a. And idea 2, identify the inner function and outer function.